If hypothesis testing feels like another language, believe me, you are not alone. In this video, I'm going to explain to you why it's so confusing, give you the explanation your teacher probably never gave you, and give you one analogy to finally make it make sense. That involves a courtroom, some evidence, and deciding whether someone is guilty or not. By the end of this video, hopefully you will understand exactly how and why hypothesis testing works instead of just memorizing steps. If you find stats confusing, believe me, you're not the only one. I'll let you in on a little secret. A lot of teachers don't like teaching stats for the very reason that it is confusing and there's a lot of jargon that you need to get through to even be able to understand what's going on. Most students don't find it easy, and even my dog finds it a little bit difficult. And yes, that was a little bit of an excuse to put a picture of my dog in there. The first shock is that the language is just completely different. So let's have a look. We've got the stats language and we got normal language. So instead of saying what we suspect to be true, we say alternative hypothesis. Instead of saying what we assume to be true, we say null hypothesis. Instead of saying how much proof do we need, we say significance level. How strong is our evidence? That one is p-value. And our actual evidence, the evidence we get from doing our test, that's our test statistic. You can see actually that these are quite simple ideas. If I said to you how much proof do we need or how strong is our evidence, you'd be quite comfortable understanding the idea behind that. If I said to you p-value, it just feels like another language. It makes you shut down automatically. The second shock is that the type of question is completely different. Before, you had a question that asked for a definite answer. You knew that if you used a certain amount of logic, you would get to a secure answer that you know was 100% true. Now, we're working with a balance of probability. There's a 3% chance that maybe we're wrong, but we're going to make this conclusion anyway. It's kind of confusing. We also start the question by assuming the opposite to what we're trying to prove is true. So the null hypothesis is the assumed truth, but we're trying to prove the alternative hypothesis. So it's, again, completely different. So what's actually broken? And that's how it's taught and how it's examined. The exams use technical language. The textbooks use technical language. Teachers often just teach the steps. And if you found yourself memorizing and trying to rote learn all the different steps without actually understanding what's going on underneath, you're not the only one. And it's quite frustrating, actually, isn't it? So what's the missing piece? Well, behind every hypothesis test, there is a story. And I'm going to share with you a courtroom analogy that hopefully will make all of this make sense to you. In the UK, we have this idea that everyone is innocent until proven guilty. So we assume innocence and the prosecution have to prove the guilt. You don't have to prove your innocence. You don't have to bring evidence to prove your innocence. So you might remember the case of where there was this famous tree. It's called the Sycamore Gap near Hadrian's Wall, was cut down by two men. It was a really iconic tree. So this was a huge deal at the time. And I'm going to use this as our little example. In UK courts, we are told that we have to prove beyond reasonable doubt someone's guilt. So they're assumed innocent and then we prove beyond reasonable doubt that they are guilty. So ask yourself, what percentage would you be happy with? Percentage certainty would you be happy with to say that's beyond reasonable doubt? 95% sure? 99% sure? 99.5% sure? I'm going to go with beyond reasonable doubt, let's say 99%. We might think actually that's too low. You want to be more certain. If you're going to send someone to prison or you're going to give them a criminal record, you'd want to be more sure than that. There is no number in the UK. This is not a value that you can put a number on, but we're just going to put a number on it for the sake of understanding stats. Let's say we want to be 99% certain. Our H0, our null hypothesis, is they are innocent. That's what we're assuming to be true. And the alternative hypothesis that we're trying to build a case for is that they are guilty. The evidence against them in this case is that they were seen walking in the area of the tree. Let's say that's our evidence. Now, we're going to assume they're innocent. This is our test statistic. This is our test as our evidence that we've got to prove that they're guilty. So we assume their innocence and we ask, okay, if they're innocent, what is the actual chance that they would have been walking in the area anyway? So they've never been out hiking together. They're not a hiking family. They don't live anywhere near the site. I'm making up these numbers just to prove a point. But let's say the probability of them walking in the hill near the tree, if they were completely innocent, is 0.5%. Have a think about that. 0.5%. That's really low. That's under 1%. That's so unlikely that we are going to think maybe this assumption that they're innocent is not true. Does this pass our test though for beyond reasonable doubt? We said earlier we're going to use 99% for our certainty level, which means a 1% chance that we could be wrong. So we're happy with a 1% chance that we could be wrong. In this case, there is a 0.5% chance that we could be wrong. If they were innocent, there's a 0.5% chance they could have been walking near the area anyway. But we are happy. We set out at the beginning and said beyond reasonable doubt means 99%, so 1% chance we're wrong. So because 0.5% is now under our 1% uncertainty level that we were happy with at the beginning, then we're going to say that they are guilty. Now, just notice here, significance level is 1%. This was the boundary that we set at the beginning that says, okay, we've proved it beyond reasonable doubt. This bit here is the actual probability that if they were innocent, they were walking in the hills. So if we convict them as guilty, there is a 0.5% chance, actually, we've got it wrong. Okay, but we've got to set a boundary because we're never going to be 100% certain. So this boundary is something that we decided at the beginning we were happy with. Okay, this is so unlikely that we reject H0 that they are innocent and we say, actually, there's sufficient evidence that they are guilty. And we locked them away for a very long time. And that's it. That's all those complicated words are hiding. If you want to see how to put this into practice in real hypothesis questions, click on this next video now to see my exact 6-step process that works for every single question.